I wanted to talk a little bit about what this code is doing conceptually before looking at the actual implementation of the code. So I want you to think about each of these game levels as stackable objects. So something that you can put inside of a typical computer science stack. Right? Right now, right, we only have one level. So adding more could be a matter of putting something into a stack. Okay? And you can imagine that whatever happens to be at the top of the stack is the thing that's being displayed right now. Okay? And you can, the nice thing about that is you can remove something from the stack, and whatever was behind it, right, you're able to display that information again. Okay? A sec. Right, so you push things onto the stack, like a title screen. Right? Let's say we have the Super Mario Brothers 3 title screen. Right? A little Mario running on the bottom, press start to begin, whatever you want. Right? We would have that screen show up first. To do that, right, we would just have to put it into the stack. And since it's the top of the stack, it's the one that's being displayed right now. Okay, so if you ever wanted to go onto a different screen or have something else show up, if you wanted to go into a different level, all you would have to do is push that next level onto the screen. Okay? And you just do that by calling methods on that stack. So, right, you press start, you go ahead and go, and the idea is you go and start the game. This pushes the game screen onto the stack, like we've got here. And again, whatever's on the top of the stack are the methods that you'll call, right, in order to actually display and interact with that particular screen. Okay. Right. So in this particular graphic, game screen is up at the top of the stack, and that's the one that we're going to be interacting with. Now, another nice thing that this particular interface does is that if you happen to pop everything off the stack, right? If we remove the game screen, then remove the title screen, the stack is empty, which in this case means that the game is done, right? We can actually be all the way done, right? We can quit the program, we don't have to worry about it anymore. Right? It keeps track of when you want to be able to quit the game. Okay, so the thing that's handling this stack is, I call it level manager. And what it is it's actually a singleton. And we'll kind of look at each of these terms, right, what singleton is, and then look at the actual code of the level manager as we're going through. The bottom note here is that for the more advanced students in the room, you might think, wait a second, this would probably be better as a state machine. Right? So I'm at a particular level, some series of actions occurs, and then I'm in a different state. Right? Then some series of actions occurs, I can transition to a different state. And then I could transition to wherever I wanted to go, right? I could go all the way back to the beginning if I wanted. I could go all the way over here, go down here, right? Like a state machine. And that's probably true. But I wanted to have something a little bit simpler to kind of build upon, right? So we'll look at state machines if there's time later. But we'll look at this stackable idea first. And it's what'll be used in your assignment. Okay, so first, what's a singleton? The idea is that you have a class that has either 0 or 1 objects associated with it. Right? Typically, you have a class, you can make a whole bunch of them. Right? If I have an animal class, I can make all sorts of animals. Right? In this particular case, I only want 1 level manager. Right? If I suddenly have 2 level managers, it's a problem. I'm like, which one should I pay attention to? Right? So having this software construct of having a singleton allows us to make sure that there's only one thing that we're actually adding and removing those screens, those levels from. Okay, so in UML, right, you would see this as whatever the name of your class is. You have a private, right, it's the minus sign there, instance variable that refers to the object, right, the class there. Okay, so this would be the one instance of this class. Okay, then there is a private constructor, right? So the only place that you can actually call create objects of that type is inside of the singleton class, right? You can't do it somewhere else, right? You have to do it inside of that class. And so the only place we can perform some kind of access, right, the thing that's not encapsulated inside the class, is this getInstance method, right? So that we can actually get that particular instance variable that we've prepared right? And again, so there's only either 0 or 1, depending on the implementation. So here, right, some Java code for the singleton, right, would be, here's our instance. It's private, right? Static meaning there's only the one. Final meaning we can't change it, right? And we create it immediately, right? So we just create that one singleton object right away. Okay? Private meaning we can't construct this anywhere else. This is the only place where we're ending up constructing. It's actually a pretty short file, right? And then this last get instance, right? We're just returning that particular object. Right? There's no way to make any more objects, there's just the one object. Okay. Now how do we do this in Python? It looks a little bit different. Partly because we don't have access modifiers in Python, so we have to go around it a little bit using some different things. Okay, so this is actually what's inside of your, if you would open up Level Manager, this is what's inside of there right now. So you can kind of see, first of all, things that are the same. Right? So first, class level manager, we know what this is, right? We can create a class. It's derives from object. Right? But this is kind of new, right? So we have this inner class, right, which has 2 underscores next to it. Okay? This, by having this class inside of this one, it's actually not possible without some contortions to actually get at this class. This is the closest thing we can get to kind of building in pure encapsulation inside of Python. We can put this inside of here, so we have to do some extra stuff in order to get at that class. Okay? And like it says, right, inner class, this is where the implementation goes. So this would be where we would create our level stack, right? The conceptual model that I talked about earlier, where we're pushing on screens, popping off screens, right? That's where we'll put that. There's still an instance variable, and right, this is on this indentation level, so we have an instance there that we can get. Okay, now actually creating the instance, the way that we change it is inside of the constructor here. Okay, so we've got a constructor. If we call level manager, right, to create a level manager object, rather than creating a brand new object, what it does is it checks to see if that instance variables have been set to something. Right? If it hasn't yet, we can create one. But we're not creating the class, we're creating an object of the inner class. Right? This is, we're creating level manager dot underscore level manager. That's the internal, right? The inner class there. Okay? So that means that we'll have just one instance. Right? If we try and call this, if we try to construct another one, right? We try to call level manager again. Right? If not level manager.instance, that'll be false, right? We'll skip it. It'll only ever create this once. Okay. This second bit, right, this function here, getAttr, what it's doing is it's getting attributes and pushing it into the instance. So normally if you would call, there'll be a getCurrentLevel, right, that will have to peek at the top of the stack. Right? Normally if you would call level manager.getCurrentLevel, it's going to be looking for a def somewhere in here, right, at the first level. Right? But we want it to look inside of that inner class, right, that's hidden away, and hidden away on purpose. Okay? And so that's what this does here. Right? It actually goes into that middle class. Questions?